So when we are looking at polygons, we want to first of all classify whether a shape is a polygon or whether it's a non-polygon. From there, we can actually then classify it further down when we know whether the shape's a polygon or whether it's not. So on this T-chart, what we're going to do is list the attributes that make a shape a polygon and list the attributes that would make a shape a non-polygon. So for polygons, you need to have straight sides. So there can be no curved sides. So for example, something like a circle is not classified as a polygon. So if you have any curved sides on your shape, it would be classified as a non-polygon. Next thing that classifies a polygon is that it has to be a closed figure. That means that for a non-polygon, it is an open figure. That means that two of the sides aren't meeting at the vertex. Then the last part is that the sides only meet at the vertex. That means they can't cross each other. That means on here, for a non-polygon, the sides cross each other. So these three things will classify whether a shape is a polygon or a non-polygon. If it has straight sides, all of the sides are straight, then it can be a polygon. If it has a curved side in it, such as something like this, then it can't be a polygon. It has to be a closed figure as well. So that means it can't have any open sides. Something like that, not a polygon. And the sides only meet at the vertex. That means they can't cross at any point. Something like this, not a polygon. Now, for it to actually classify as a polygon, all three of these have to meet the standards in order for us to say, yes, it's a polygon. So let's look at these four shapes, and we can then look back at our T-chart and say, is this a polygon or not? So when it comes to this one, here, I'll bring this in. When it comes to this shape, does it classify all of these here? Well, it has straight sides, yes. Is it a closed figure? Yes, there's no open sides to it. Sides only meet at the vertex. No, it's actually crossing here right in the middle. Therefore, this one is a non-polygon. So let's take a look at this shape here. Straight sides, yes. Closed figure, no. It's actually open right here. The sides only meet at the vertex, yes. But because it's not a closed figure, it's an open figure. This is a non-polygon. This shape here, straight sides, actually no. It's got one curved side right here. So we already know it doesn't fit into the polygon. Is it a closed figure? Yes. Do the sides only meet at the vertex? Yes. But because of this one line being curved and not straight, it's a non-polygon. Now let's take a look at this one. Straight sides? Yes, all the sides are straight. Closed figure? Yes. Sides only meet at the vertex? Yes. So this shape, even though it's a bit funny looking, it is classified as a polygon. Once we know whether a shape is a polygon or a non-polygon, we can then classify down polygons being regular polygons or irregular polygons. Now again, the classification for being a regular polygon has to have all of them be on there, all of the attributes. And for the irregular ones, all it takes is one of these to not be an attribute for a regular polygon, and it automatically becomes an irregular polygon. So let's look at the attributes for a regular polygon. You have at least one line of symmetry. That means that if you were to actually split the polygon into two halves, that when you fold it together, it would be mirror-like. Now, all you need is just one line of symmetry for it to be a regular polygon. Other thing that you need is that all sides are equal. All sides, remember that. You also need that all angles are equal as well. So that means for an irregular one, no line of symmetry, not all sides are equal. That means some could be equal, but not all of them. And not all angles are equal. That means, again, some of them might be equal, but not all of them. I've collected some things around my house that we can use as examples in order to classify if something is a regular polygon or an irregular polygon. So we're going to take a look at some of the shapes. These are Tilly's shape blocks that we have here. A cookie cutter star here, and look, a Guardian gold ticket that we're going to be looking at as well to see whether can we classify these as regular polygons or irregular polygons. Let's take a look at the hexagon first. So with this one, what we have, remember those attributes that we have. So does it have at least one line of symmetry? Which it does. It actually has many lines of symmetry. You have that if you were to split it right down these two vertexes here, you have one line of symmetry, two lines of symmetry, three lines of symmetry. So that part of it classifies it as a regular polygon. Are all sides equal? Well, yes. All these sides, actually, if we were to go and measure them, 2.5, 2.5, 2.5. All 6 of the sides are equal to each other at 2.5 centimeters. So that also checks off the box. Are all of the angles equal? Now remember, when we're looking at this, we're looking at the angles that are inside the polygon. So we want to make sure that all of these are equal to each other. I'll give you a little secret. If the sides are all equal, then the angles are going to be all equal. So that also checks off the box as yes, this shape right here is a regular polygon. What about this triangle? Now, all 3 sides are equal. All 3 angles are equal. And it actually, again, it has 3 lines of symmetry. if you split it down the middle here, 1, 2, 3. So this also classifies as a regular polygon. What about our star? Now our star has sides that are equal to each other. It also has many lines of symmetry again. 1, 2, 3, 4, 5. However, with the star, not all of the angles are equal. In fact, it has 1, 2, 3, 4, 5 acute angles. But then we also have to classify these angles here because this side and this side meet at this vertex. This is a reflex angle, and it's got 1, 2, 3, 4, 5 reflex angles. So 5 acute angles and 5 reflex angles. And even though those reflex angles may be equal to each other and the acute angles may be equal to each other, they're not all equal to each other inside the star. Therefore, the star is actually an irregular polygon. The square. The square, again, has many lines of symmetry. It has 8 of them because you can take a square and go halfway, but then you can also put it this way. All sides are equal on a square. That's one of the attributes of being a square. And all angles on a square are 90 degrees. Therefore, a square is a regular polygon. The parallelogram. Now, all sides could be equal, and on this one, it actually is. You do have lines of symmetry. You have 1 line of symmetry, 2 lines of symmetry. However, the angles are not equal. These 2 angles are equal to each other, but they're obtuse. These 2 angles are equal to each other, but they're acute. Not all of the angles are equal. Therefore, this is an irregular polygon. The trapezoid. Now, for this one, we have that there are lines of symmetry. Right down here is a line of symmetry, so it at least has 1. But not all the sides are equal, and not all of the angles are equal. This is an irregular polygon. Then you have the rectangle. This one always kind of confuses people because you think it's a rectangle. You have many lines of symmetry, again being 2 of them straight down here, down the middle, and down the middle. You have all 4 of the angles being equal to each other, 90 degrees, in order for it to be classified as a rectangle. But not all the sides are equal. 2 sides are equal to each other, and 2 sides are equal to each other. That's the difference between squares and rectangles. So that means not all 4 sides are equal. Therefore, the rectangle is classified as an irregular polygon.